All right. Hi, I'm Howard Kelly with S&S, and I'm here with Jason Schmidt. He's our Core Product Engineering Program Manager. And today, on our episode of Proven Performance, we're going to talk about torque and horsepower and the difference of torque and horsepower. So Jason, if I put you on the spot and I ask you to explain the difference between torque and horsepower, how would you start that answer?
Well, first I would probably talk about first defining what torque is. Torque is a characteristic of each engine, each internal combustion engine, and then horsepower is related to torque basically by time. So they're intimately related, but torque is typically the measurable thing that we measure on, like a chassis dyno, for example, or a engine dyno.
Okay, and how does that matter in a V-twin engine?
Well, they're both characteristics that people want to know about, but torque is force. Torque is the motion that moves a vehicle down the road.
No, horsepower moves it down the road.
Horsepower is also needed, but it depends on your application. Horsepower is typically used for racing. You want a high horsepower engine for racing, vaudeville, road racing, and whatnot. But torque is again that motion that moves a vehicle from stop to stoplight or stop to on ramp. So that's primarily what torque is important for.
So, for example, if somebody says my motor makes a lot of bottom end torque, what does that mean?
Well, it means a couple of things. It means that they have probably a large displacement engine. Typically a larger displacement engine, or A to B comparison. If one displacement is larger than the other, it's going to have more torque than the other. But bottom end torque is kind of what it means. Is bottom end being the lower RPM range of the engine. Mm-hmm. So if they say they got more low end torque, it means like from idle to 3,000 RPM, they've got a lot of throttle or a lot of torque where they can twist the throttle. Accelerate the vehicle or the bike smoothly and strongly.
What makes torque? I love asking these questions.
Yeah.
It's great. He has no idea what I'm going to ask.
I didn't have a script beforehand. Torque is influenced by a couple of things. It's mostly your stroke length of your flywheel assembly, and then essentially the bore of the piston. And then there's other things like camshaft design, which has influence on torque, but really it's displacement. The old adage of there's no replacement for displacement. That's really what creates torque. Is something with more displacement, meaning bigger bore, bigger stroke, will create more torque.
And typically that bigger displacement will make torque earlier in the power curve, right?
Correct. I guess if you do apples comparison, if you have engine A, engine B, and engine B is 10% larger displacement, that torque curve is going to be shifted up all the way through the RPM band accordingly.
Okay. So at S&S, we primarily focus on V-twin engines.
Mm-hmm.
And I know we make performance packages and they're designed for different things, but as a core product engineer, you're primarily focused on street application, right?
Yes.
So what matters for the street?
Torque. Torque is what moves a vehicle down the road. It gets it started to go to the next stoplight as quickly as possible. It makes the vehicle fun to ride. And
why does it make it fun to ride?
Because you don't have to ring out the engine. You have to ring out the engine to 6,500 RPM to pass around the truck. You can be loafing around along at 2,000 RPM. You don't need to downshift if you got a ton of torque. Just open the throttle and you can smell it, accelerate smoothly around whatever you want to on the highway.
So, and Jeff and I did a video a few months ago or a few weeks ago, I forget what it was now, where we talked about how cams have an effect on power curves and how horsepower and torque and things like that relate. If I'm building my bike to be a fast, fun street bike, and we'll say the average V-twin Harley, S&S engine, whatever, runs from 0 to 6,500 at really the extreme of what they can spin to. Mm-hmm. Where do I want the torque?
Again, it depends. If you're looking for highway cruising, you want torque in that idle to 3,500 RPM range.
I want to beat my friend's traffic light to traffic light.
So you can. So we do have different cams, which will kind of shift that torque curve around, right? So we've got like a low end torque touring cam, but if you want to do stoplight to stoplight, that mid range, a nice healthy increase in mid range torque would be probably a good application for just normal street driving.
Because traffic light to traffic light, I'm probably not getting the 6,500 RPM between the gears.
Could possibly. Again, depends how you want to ride it. But I think in that scenario, if you had plenty of torque, you wouldn't necessarily need to ring up the engine. You could kind of shift down to a lower gear and then still be in that really healthy part of the torque curve.
You have some parts here. Tell me why.
Yeah, I talked about stroke. What's the stroke of the engine? I brought a crankshaft flywheel assembly half over here to show really what that means. This is get up here and kind of push the head. But this is half of a flywheel, the drive side of the flywheel, so it's got the output shaft, which would connect to your compensator portion of the drive. But really what we're showing here is the crank pin location. So what I'm emphasizing here is the stroke length is basically the diameter that the the connecting rod pin travels. So basically from the center of rotation to the center of the crank pin is 1/2 your stroke length. So you multiply that by 2, that's your full stroke length. So again, if it's a 4.5-inch flywheel, the stroke length would be half of that, so 2.25 inches.
Okay.
And then other things here.
4.5-inch stroke length. You said that like it was just is that a common?
Yeah. So stock Harley Davidsons come with actually 3 common stroke lengths now.
Which stock Harley Davidsons?
M8s.
Okay.
So the 107 bikes, they have a 4 3/8 flywheel, 4 3/8 stroke length flywheel. The 114s and 117s have a 4.5-inch stroke flywheel, and the 121 CVO bikes have a 4 5/8 stroke flywheel. So S&S makes flywheel assemblies at all 3 of those strokes as well.
What is our 136?
Our 136 is a 4.320 bore piston with a 4 5/8 stroke flywheel assembly.
Big.
Yeah, so that's what the biggest, baddest engine that we have so far
Nice.
for M8s.
And pistons?
Yep, this is a good example of, displacement increase. So the larger you can make your piston, the more force that will exert on your crankshaft, and then the more force will in turn lead to more torque. So this is a typical, I think this is a stock, probably a 107 piston. It's about 4 inches in diameter. And then we've got pistons we're working on in various displacements that I just really want to emphasize the big increase in displacement, typically by increasing the bore of the cylinder. So again, stock versus a big bore. Again, that almost being the same. If the cylinder pressure is the same, it's going to exert that much more force on a larger diameter piston than a smaller diameter piston. Again, that more force, that increased force, will push down through the connecting rod harder and push down on the crank pin harder, creating more torque.
People always talk about, my bike makes this much horsepower. You never hear people brag about torque.
Mm-hmm.
But everything you've talked about so far is torque is what really matters. Why is it that we brag about horsepower and not torque?
Probably because it's so ingrained in people's thoughts, and that's what's advertised primarily on, sell sheets, car magazines. The first thing they do is measure the horsepower in the chassis dyno. Race cars, race motorcycles are all measured in horsepower. I think it just, that's part of what people are used to hearing.
But the reality is if somebody's not even just looking at our stuff, but looking at any performance upgrade in a V-twin bike, which not to say that they don't like to rev to 6,000 RPM, it's just, in my experience, they're nowhere near as comfortable at 6,000 RPM as they are at 3,500.
Right.
That's the bigger focus then, right? Because you want the ride to be comfortable, you want the ride to be enjoyable, and you don't want to have to drop 3 gears on the highway to suddenly accelerate.
Yeah.
You want to be able to be in 6th gear and just roll on the throttle and go.
Exactly. I think you really got to think about how you ride the bike, what type of mode, what RPMs.
Well, I have it pinned in the stops all the time when I ride, man.
You do?
All the time. What happens to an engine that's pinned to the stops all the time?
There's a lot of wear and tear, a lot of stress on the component, a lot of stress on bearings, connecting rods, rings. So it definitely can potentially shorten the longevity if it's full throttle all the time.
Yeah, I'm joking. Nobody, despite the people that you meet at bike night and stuff, nobody really rides throttle pinned all the time unless you're doing burnouts in a parking lot because you're getting paid to do a stunt show.
Exactly.
Which, by the way, is that good for the engine, banging it off the rev limiter like that for 20 minutes?
It's not great. I'm sure there's some unintended consequences I can't think of right now, but we typically, when we're doing a dyno run, if you hit the rev limiter for a second or so, that's your evidence to stop. The dyno run's over.
Mm-hmm.
I guess we never run it that long up to the rev limiter, I guess, but I'm sure it would be causing some problems.
I'm sure you've seen the guys doing that in little stunt shows and stuff, and it makes me cringe because I always think about if that was my motorcycle.
Exactly. They're probably used to working out, so they'd probably be billing it every other month.
Yeah. Didn't you bring something else you wanted to show us?
Yeah, do you want to take a look at the flywheel?
Yeah, I do.
Crankshaft assembly. Yeah, let's show the grab that.
So it looks like you got half an engine here.
Yeah, really what I wanted to show here was kind of the interaction between the piston, the connecting rod, the crane pin, and then the flywheel assembly. Just really simply just a half case, half of a S&S case with a half S&S flywheel with our connecting rods, pistons, and cylinders. So again, the stroke...
Beefy looking connecting rods.
Yeah, they're very, very durable. So, they go into every single M8 engine we build.
We have stuff beyond M8 like this, right? We have stuff for twin cams and V-series engines and...
Correct. Yeah, it's all...
Don't want everybody to think we only want to talk about M8s here, but...
Yeah, all this stuff.
That's our current project list, but want to make sure everybody knows whatever he's talking about with this relates to our twin cam and Evo components, which you can't get at your local Harley dealer anymore.
I want to emphasize again what the stroke of the flywheel is. So stroke, again, is how far the pin moves from top to bottom. So basically, if this is the rear cylinder. If the rear cylinder is at bottom dead center, the crank pin's at bottom dead center, and then this would be top dead center for that rear cylinder. So again, that distance that the pin travels is the stroke of the flywheel assembly. And again, really, what the piston does is when the combustion happens, it pushes down on the connecting rod, which in turn pushes down on the crank pin, and that interaction creates the force or torque, if you will, on the engine. So what the different stroke lengths do is the longer the stroke length, the longer your lever arm. So again, the lever arm, think of like a wrench, right? A torque wrench. So it's much easier tightening a bolt or loosening a bolt with a long wrench than a short wrench. So think of the center of the flywheel assembly to the center of the crank pin. That's your lever arm. So the longer you can make that lever arm, the more torque you can have your basically your flywheel exert throughout the rest of the drivetrain.
Okay. So what we're looking at is what length stroke?
I believe this is a 4 5/8 stroke, yes.
So this is a pretty big engine then, right?
Exactly.
Is this part of our 136?
This actually has some new test components in it, but it's got the same flywheel assembly that's in our MK136. And
Wait, so we shouldn't show this to everybody because this is...
Well, they're not... I mean, the pistons are new, but no one's gonna... I mean, we don't need to show that as far as the diameter of the piston and everything. But okay.
Sometime we'll tell you what this actually was, people, but for now, just know that you're seeing something that I didn't know Jason was going to show.
But the appearance we have here is the same as in our MK136.
Okay. So back to the difference between torque and horsepower.
Sure.
What kind of stress goes on this assembly at 6,000 RPM versus, say, 3,500 RPM?
It's substantially higher. The amount of force that the bearings need to basically hold back, and then the surface of the crank pin, it's substantially higher. I don't have a good number.
I'm not looking for. I mean, just like it's a big deal, right? When you are at 6,000 RPM, the speed of everything. Yes, I know it means it's moving at 6,000 rotations per minute, but getting oil on the bearings, keeping them cool.
There's a lot of stuff that needs to happen. Exactly. Oiling is huge. You want to have enough oil in the flywheel cavity to make sure everything's properly lubricated, but you won't have too much oil. If you have too much oil, it can lead to things like stumping, excessive oil temperature, which can cause lots and lots of problems. So oil control is huge. Again, for longevity and durability.
So what else should we talk about with this? Or are we done talking about this, and should we kind of wrap up with getting back to my original question on the difference between torque and horsepower?
Yeah, I think this is kind of the main emphasis I wanted to show you.
Oh, you know what? Just for the heck of it, just in case someone's never seen it before.
Sure.
Could you roll this through 1 or 2 rotation cycles? Because people have to understand how the pistons in a V-twin move.
Yeah, it's very unique, isn't it? I mean, there's not many engine designs like this. It's an old engine design, but yeah, I mean, this is a super good visual reference as far as how everything does interact together. So
right now, both of the pistons are up top.
Exactly.
But I think when people look at a V-twin, I think they think that one is at the top and one is at the bottom, and one is at the top and one is at the bottom.
Exactly.
And that's not what happens, and that's where the unique sound of a V-twin comes from, correct?
Exactly. So with the common crank pin, the firing order is uneven from rotation to rotation. It's not an even 360 degree firing rotation. It's split, so you get a kind of that loping sound. So again, that common crank pin, knife and fork style connecting rod setup is what kind of makes the harmony.
So on the next cycle, both of the pistons come down.
Exactly.
Correct?
So this is basically at bottom dead center.
And then one of these 2 cylinders at this point is starting to get fuel pushed into it, right?
Probably before that. So actually backing up. So as this is probably the front cylinder.
Yeah,
So if this was on the intake stroke, as the piston is coming down and the intake valve is opening, it's drawing in air and fuel. So at this point, when it's near the bottom, it's pretty much it's drawing in all the air and fuel that it could possibly take in, and then the intake valve is actually nearly closed or closed at this point. So as the crankshaft is rotating up, it's starting to build pressure. So again, with all the valves closed on the front cylinder, the volume is decreasing. So when the volume is decreasing, the pressure increases. So at this point, somewhere before top dead center is when the spark plug will fire. And
then this cylinder fires.
Yes.
And isn't it a full rotation now, and then until that cylinder fires?
It's going to be actually less than a full rotation. It's going to be 360 minus 45 degrees. So as the front cylinder is firing, now is when the rear cylinder should fire. But then now there's a lag time between when the front cylinder or the rear cylinder fires. It's actually going to be a full revolution, and then 45 degrees before the front cylinder fires again. So you get that uneven firing order.
Right. I think I love that. Like, it fascinates me because you sit on a V-twin and you just assume that they're going opposite each other, when in reality it's this. And
exactly.
That's unless you see something like this, you never get to experience that.
Yeah, that's another good reason I brought this up. It's interesting to see this.
It's great. Jason, this is a fantastic lesson in a whole bunch of stuff. I hope we explained horsepower and torque in this video. Obviously, like we said in past videos, if you have any questions, please get in touch with us at S&S, and we'll try to answer your questions. Jason, thanks for your time today. I appreciate it.
My pleasure. Thank you.